Hello and welcome to today's webinar, 7 Key Considerations for Kubernetes Backup, brought to you in partnership with Veeam. This event is part of the Veeam TrailBlazer Talk series. Hopefully you have been on one of the previous Veeam TrailBlazer Talks and have seen this amazing series of events. If not, I encourage you to check them out and of course look for future invitations to the Veeam TrailBlazer Talk series. This is going to be a fun, fast-paced event. We want to help to answer all your questions around Kubernetes backup. And as more and more companies are moving their applications to cloud-native architectures, protecting Kubernetes and those cloud-native apps is becoming so critical. With that, let's go ahead and kick off just a few things you need to know about the webinar. My name is David Davis, and I'm serving as the moderator today. We want this to be educational. We encourage your questions there in the questions pane, and we want to help to solve your challenges around Kubernetes backup and cloud-native data protection. So we'll be doing a Q&A session at the end of the event, so keep your questions coming during the presentation. We also have a number of resources there in the handouts tab. I encourage you to check out specifically the Kubernetes backup and recovery guide for dummies. You can download that free educational ebook right there in your handouts tab. And then at the end of the webinar, I'll be announcing the winner of our Amazon $300 gift card door prize. If you're watching this on demand, of course, that drawing has already occurred. The prize terms can be found there in the handouts tab. And then I also want to point out we have our best question prize today as well for another Amazon gift card, a $50 Amazon gift card. Of course, you have to ask a question to be entered into that drawing, and also meet the Actual Tech Media prize terms and conditions. And with that, I'm excited now to introduce you to today's expert presenter. Welcome, Mr. Michael Cade, Senior Technologist for Product Strategy at Veeam. Michael, it's great to have you on. Let's go ahead and kick off this Veeam TrailBlazer Talk event.
Yeah, thanks, David. So, yeah, as the title suggests, we're going to be focusing in on 7 key considerations for Kubernetes backup. So if we move on to the first page, and just to give a bit of background on myself and where I've come from, and maybe a lot of us in the audience are having a similar trajectory in terms of understanding a bit more around Kubernetes or the cloud native world. But so I'm Michael Cade. I'm a senior technologist here at Veeam, but I'm focusing at the moment around Casten by Veeam, which is a focus around data management within Kubernetes. So, but I have a lengthy background when it comes to data management. I've been focused in this space around virtualization, around backup, around storage for the last 16 years, and also a strong community first approach to technology, really, about sharing information, be it through different content media, through blogs, through tweets, etc. And encourage anyone that's got any questions that we don't get to today, if you want to ask them, either obviously from the platform point of view, but also come and find me on Twitter. It's feedback, it's questions from the audience that really gives us some good understanding about what we need to cover in these sessions moving forward. So that's a bit about me, and where you can find even more about me and also to contact me. I want to kick off by introducing really around, or building the picture up around data management and the requirements around data management within Kubernetes. And first and foremost, as cloud native, like, adoption is rising. We're continually seeing the adoption, the numbers, the stats coming out there, the analyst reports, etc., coming out there around Kubernetes, and cloud native as a wider industry adoption rate is really exploding. And obviously, with what we've learned from physical backup requirements or data management requirements, as well as virtualization, it seems to be that day two operation is very much more top of mind. Like, we're definitely having more conversations around backup first and foremost, but then also disaster recovery and everything along them lines to begin with. And just some of the data points here on this slide indicate that there's a lot more Kubernetes clusters being rolled out into production than maybe we first initially expected, and that adoption being much faster than what we maybe saw from a virtualization standpoint. Now, don't get me wrong, I'm not going to come on here and I'm not going to start saying about, oh, virtualization is going away and containers and Kubernetes is taking over the world. That's never going to happen. In fact, one of my biggest bugbears is when you go onto your web search, Google, for example, and you type in containers and virtualization, just wanting to understand maybe a bit of the differences between, everything comes back as versus that negativity about having to trade one for the other, and that's simply not the case. They can absolutely live alongside each other, but they have different requirements, much like that journey that we went on from physical to virtual, and that we saw a lot of traditional backup vendors at the time roll their agents into virtualization, and you still had all of that massive overhead, the administration around having to look after those agents. And I think that's a key stake in the road where we are here as well, in that, okay, we've kind of got the best of breed from a virtualization point of view, from being able to protect our virtual machines in an agentless fashion, because the nature of where Veeam pioneered that trajectory was being able to protect those workloads in an agentless fashion. And it was done by leveraging the underpinning vSphere API and all of that good stuff. Now we fast forward into Kubernetes and we see exactly the same challenge, is that, well, we can't take that traditional model. We can't take the virtualization approach to be able to protect those workloads, because not everything's running on vSphere. But we also can't take the agent approach either, because, again, like, we don't have the underpinning knowledge of what it looks like under the Kubernetes API. So in order to be able to protect those workloads, we need to be living that Kubernetes API. And I'll get on to more about that later on. But you can see here that the large amount of respondents to the survey that VMware held was quite compelling to suggest that people are running Kubernetes not only for a test and dev and a toe in the water, but actually a large amount are actually running it in production with a considerable amount of nodes within that cluster, or considerable amount of clusters itself. So that was quite an introduction into cloud native adoption and how we continue to see that. And I imagine everyone on the call is at various different lengths of their journey, whether it's they're running everything in production and you're approaching a DevOps mindset, and everything around delivery of applications is first and foremost and top of mind for you. But then there's also going to be people on the call that are very much on day one, or maybe even further back, and don't have that understanding of Kubernetes in general as a platform. So we're going to try and cover some of that area today. But I think what I'd also say is that data management is a requirement, regardless of platform, whether it's physical, virtual, cloud, or cloud native. Kubernetes involved in there. Data management still has a place, and it's still just as important as we see from a security point of view and visibility point of view. So I think also what we've seen, and I've been really focused on casten and Kubernetes for the last 6 months, as in my day job has been completely living in this community. And before that, we're probably looking at 2 years of having an understanding around Kubernetes clusters, the infrastructure behind that, etc. And I think it's fair to say that the day one operations, it's very easy, simple to deploy a Kubernetes environment, whether that be in the public cloud, whether that be on your local laptop, your development environment. But really, that first step into this world has really been accomplished. Yes, there's other areas that can be achieved and be improved, especially around like a visualization, UI management, etc. And we're seeing projects pop up everywhere around that. But really, that was the initial problem, and was around provisioning that cluster, and that's pretty much like sorted for now. So what we then get to focus on is all of the stuff that we leave at the bottom. It's not the exciting stuff. It's not the picking out where we're going to run things. It's not the shiny new stuff around storage or compute or networking. We now get down to, okay, security, around observability, around data management. And they're the challenges that are now becoming to the forefront of businesses, especially those that have outlaid a massive investment in Kubernetes within their environment. And you could broaden that out to the cloud native world as well, is that because we're able to get there faster from a community and open source perspective, we can get to day 2 quicker. If you remember from a virtualization point of view, it was very much, at least from my point of view, being in that world, is that backup was always at the bottom of the list alongside some things like security. And actually in the news, we're seeing daily reports on things like ransomware and other areas of interruptions and failure scenarios that we have. So there's some of the areas, and this is where the focus is. This is where it's about educating the world or the community about, in our case, around data management, but also know that that's very tightly coupled with security and observability in itself as well. So I've said about that exploding day 2 use case, both that storage and the data management. There's been heaps of investment around, or innovation around, storage within Kubernetes, but also around data management. And you've seen a lot more focus around how do we improve, not only how do we take backups from A and store them in B, but also how do we incorporate our data management processes into our daily workflows, into CI/CD pipelines? How do we leverage the Kubernetes API to enable us to be more policy driven when it comes to creating and protecting our workloads? And I think this comes down to a few more dispelling the myths, if you will, around like back in the day, probably 2 years plus ago, it was very easy to say that Kubernetes was built for stateless workloads, those web servers, those self-contained containers or pods that held your web server, and it was great for that scale up, scale down on the important days of the year that you need it. But I think it's fair to say, as you can see from this report as well, from 451 from last year, I know they're working on a more up to date, and I expect the numbers to even grow even further. But we're looking at 55% of the organizations indicate that half or more of their container applications actually hold some level of state. Now, it's easy for a data management evangelist, technologist to talk about, oh, that's going to be databases, NoSQL, SQL databases. But also think about the data streaming, the batch processing, the message queues, everything that makes up of that, whether it be log processing, any of those different data services require some state, which requires most likely some level of data protection. What happens if you lose that database, that messaging queue, especially from an audit or security point of view? What happens to that? So this is where we've seen over the last few years a massive rise in stateful workloads being delivered and working on Kubernetes itself. So, but I also think it's worth mentioning around the dev and the operations team. Now, I come from very much the operations side of the house, the infrastructure guy that's keeping the lights on, that is deploying the storage that can really focus on delivering the quality of service that I want for my application, whether that be the database. And it generally lands on me when I deliver the infrastructure to our application developers, and they create their application. They give it to me in some form of virtual machine or cloud-based instance. I have to find somewhere to store that. I run that, and that's how it's always been. It's been thrown over the fence, and then it's down to me to keep the lights on, make sure that that's functioning for our audience, whether that be internal, external, or third-party integrations. And I think that world has definitely been massively getting closer and closer. And that's where we've seen the likes of cultures around DevOps, or you may have heard of platform ops. And that's really about these two coming together and having a bit more of a understanding around the application development lifecycle, and or the developer having an understanding of the platform where their application is going to run, and take advantage of that. And that's why that gap has been filled and the silos kind of crushed, because to make our applications better, to run better, run faster, more efficiently, then we need to have that 30% understanding of the platform, and we need to have a 30% understanding of what the application is written in and how it works, how it scales, etc. And then really we get the 70% of understanding what the platform is, and that's where you might see roles such as platform administrators, infrastructure admins, SREs. But then on the flip to that is we've got that 70% of understanding the development angle and having a stronger idea about what that's happening and merging them two together, having SREs and DevOps engineers both together working on the same outcome. So that's really what we're focusing on and how we're bridging that shift left requirement around Kubernetes, around cloud native. So from a data management point of view, and this is not necessarily talking solely about casten, but it obviously lines up with where and what we're doing. So first and foremost, from a data management point of view, I believe that the majority of people would think of backup and recovery. First and foremost, I need to back up my data. And if the worst was to happen, the failure scenario was to happen, I need to be able to recover that. But then we also have to think about how we do that in the most efficient way. Things like multi-tenancy, role-based access control, being able to be agnostic to the storage underpinning those applications, and you might have multiple storage options within your cluster, all of those various different options. Then you've got application mobility. This is something that Veeam have always strived to from a virtual machine point of view, being able to recover what you want, where you want it, or where you need it. Now, that's the same when it comes to Kubernetes. Wherever Kubernetes is running, we've got the ability to deploy our YAML manifests really wherever, and that's fine for stateless workloads. But how do we get the persistent volume and that MySQL database? How do we get that from maybe EKS to Azure to AKS or vice versa, or maybe on premises? So K10 has the ability to do that under the hood and be able to transform that as well. And then finally around disaster recovery, and here's the big spoiler, none of these really are different to what we've all come across from a virtualization or a physical or a cloud-based workload. All of these failure scenarios make up data management in general. We're just talking about specifics when it comes to Kubernetes and protecting those workloads. So there's no real difference, and actually the requirements are still very much there. So we've got obviously customers out there, and this is where we're focusing on the DevOps engineer or the architects around being able to drive that automation layer, incorporating backups into their CI/CD pipeline, and having an understanding of actually, yeah, it's easy to deploy the application. It's easy to deploy the stateful workload and get data into the database. It's only thereafter that we have to now think about the backup and the routine around that. But also, how do we then test that the backup's working and things around that? They're also all important. And you can see here from the quote is that, well, that might have not have been top of mind, but it's starting to become more top of mind for those people on the left-hand side, the DevOps engineers, even the developers are wanting to incorporate backups into their workflows so that they've got a way of being able to protect that data. And then some of the myths, I've already touched on stateless, but we can go one step further around high availability is not a form of data management. Yes, it's going to make sure that if there's a failure within your Kubernetes nodes, it's going to make sure that we distribute our workloads seamlessly over them and make sure that the health is good. But ultimately, it's not a source of backup. Where we really need to focus on, as well as replicas, is we need to focus on that data. How do we recover if there's a failure scenario as bad as fire, flood, and blood, but also just simple accidental deletion? How do we recover from that? And then to quickly move through some of these and getting into the 7 reasons why. So we know that Kubernetes is the next wave of infrastructure, at least from an application development point of view, and who knows where that comes, and it's kind of winning that container orchestration race. But DevOps engineers or that DevOps culture wants to move exceptionally quick. And platform ops, we might not know it today, but that platform ops coming tomorrow is going to want to move just as quick. The same mantra, the same methodology that we see within DevOps is going to want to be that fail fast and re-innovate and move again. And that demand for high confidence in data management hasn't gone away because we've got Kubernetes. That's the fundamental key takeaway today, is that it hasn't gone away. And deployment patterns. So we normally would look at a virtual machine, we'd put our application on that. Well, that's now changed because we're taking that application, we're splitting it down into multiple microservices, different pods, different requirements, so that we can scale it individually in the Kubernetes environment. And with that changes what our data management process needs to look like. We're no longer just looking at a virtual machine that needs to be made consistent. We're now looking at multiple pods or multiple artifacts that we need to think about 100 different things or thousands of different things in some. So that changes. We have to think about that for one. And then we also need to think about that DevOps and that shift left by incorporating the Kubernetes API. Yes, we want a UI, and yes, we want to be able to see it in the more traditional manner. And we want to be able to drive a policy-driven approach and create our backup jobs so we can see and visualize what it looks like. And that's fine for the platform ops. But fast enough is going to come around the DevOps guy wanting to incorporate that into their CI/CD pipelines and be able to focus on the application so that you can drive that continual ability to update and deliver updates to your application whilst having that peace of mind that we're going to incorporate that backup into the GitOps workflow as well. And then operator challenges. We know that things are moving extremely fast in this world. Skills gap, talent shortage, all of that stuff. But we also need to enable things like self-service. We need to make it simplified. So we don't need a dedicated backup administrator when it comes to Kubernetes. We want them to just be able to use the stuff that they already know. There's already too many overwhelming things when it comes to Kubernetes across compute, storage, networking, etc. Data management doesn't need to be a big book that they have to read and understand as well. And then application scale. I kind of just touched on this, is that we're now focused on hundreds, potentially thousands of different pods and application point artifacts to that. So it's growing, and we have to be able to take a consistent backup of that and be able to recover that and be granular when we recover that and have an understanding of what that needs to look like when we are recovering that. And it doesn't change that infrastructure and software protection gap. You've probably heard Veeam talk about the availability gap. Well, that's exactly the same when it comes to Kubernetes. It's just another platform by all accounts. Backups, but then also disaster recovery. When do we choose it? How do we incorporate that into our business drivers? How do we look at cost, and where do we store our data? Do we store it offsite in an object storage location, etc.? All of these are just different areas and considerations that we have to really bake into our thought process when it comes to data management. And then probably the most important, but I've left it until very much the end or near the end, is around security. Being able to leverage those network policies, the different authentication models. We don't want to bring something new to the party when it's already there. The fundamental infrastructure for Kubernetes is already in place. Let's leverage that as well as the API so that we're not reinventing the wheel. We're just slotting straight into the infrastructure, the architecture of Kubernetes. And then also being able to think about ransomware or some sort of accidental deletion and think about immutability. How do we incorporate the object lock API within AWS S3 or S3 compatible storage to be able to recover those compromised data points? Because ransomware doesn't go away if you go to the holy grail of Kubernetes. Those data management challenges are still very much there. And then the final thing is around ecosystem. So the cloud native ecosystem is massive in terms of you could pretty much run any application anywhere on any Kubernetes distribution. But then there's also monitoring and different areas of login and observability that, again, instead of creating a new way of being able to do this, we've got the ability to hook into the cloud native ecosystem to be able to provide some of that ecosystem visibility or visualization at least. So I kind of wanted to just hammer home the reasons for data loss within cloud native, but you could pretty much just remove that orange piece, that in the cloud, and this spans any infrastructure that we've looked after in our professional careers or even at home for personal consumption. Is that we hear the most about things like security, whether it's malicious activity, ransomware, insider malicious activity, whether it be vulnerabilities, exposing something out and letting someone in. But still, a large chunk of that pie is being taken by accidental deletion. And then thereafter, you see that. And that doesn't change when it comes to Kubernetes. And that's why there's still that huge requirement around data management when it comes to Kubernetes. Okay, so summing things up from hopefully I've got over the point that there's a data management requirement in Kubernetes. But what we have to think about is backup and recovery, that application mobility is not just backup and recovery, and then also disaster recovery. And then probably the key takeaways is, well, I want something that's built for Kubernetes. I can't take an agent-based approach here. I probably can't take a virtualization approach here. It has to be something new and that is talking directly to the Kubernetes API. I want something that's easy to use. I don't want to have to train up on the tool that I'm using. I want it to be focused around security, whether it's managing that data, encrypting that data, but also it's going to leverage things like OIDC from a authentication point of view, but also things like RBAC and also like IAM controls. And then I want it to be able to incorporate the ecosystem that I've already brought into. I want it to leverage Prometheus. I want it to leverage the different login tools out there, but I also want it to be extensible at that same angle. I want to be able to do what I want with it. I want to be able to plug it into the tools that I have within my own ecosystem. So, okay, that was a whirlwind tour of Casten, or at least Kubernetes data management. So, really, before we dive into some of the questions, is, well, how can I then find out more? So, if you click on that QR code, which is casten.io, a simple Helm deployment in a Kubernetes cluster that you may have for development, maybe it's learning, but also there's a hands-on lab. So if you don't have access to a cluster, but you still want to have access to see what K10 does and maybe a little bit more of understanding around data services, then there's also a hands-on lab in there as well. So I think with that, David, is there any questions that have come in? I see actually quite a few.
Absolutely, yeah. Quite a few. Ransomware is a hot topic in their IT organization. How does Casten incorporate Kubernetes backup into an existing disaster recovery and backup process?
Yeah, so if you look at K10, it's very similar to what you've probably seen from a Veeam or really any backup tool out there. But the key focus for us at Casten is focusing on that reliability of that data. So we have the ability to send those backups, export those backups out into object storage, which in itself should be isolated away from your maybe Kubernetes admins, but also in the most recent version, and this is being extended over our 2-week sprints, is the ability to leverage immutability within AWS S3, but also S3 compatible that have that object lock API. So really focusing on the same policy-driven approach that you're potentially aware of with other tools, mainly probably in Veeam, but then being able to leverage that object lock API for specifically around ransomware or accidental deletion as well.
Excellent. Yeah. And I like this one. Tim's asking, since you came from the operations side to the DevOps team, what did you see as the biggest challenge on making that leap?
I think actually it's the learning curve, or at least the perception that there is a huge learning curve. Like if you're a VMware admin today and your life is around vSphere and you're looking after virtual machines, and someone says, "Oh, we need someone to understand Kubernetes," and you see it as a huge Mount Everest to get up and to start learning, and really Kubernetes is only really one aspect of DevOps. You've got probably another 11 things, and I've done a blog post on that, so shout out to that. But kind of like CI/CD, I've mentioned that. What does that actually mean? What does it do? Configuration management around like Ansible, and people have heard these terms, but what do they actually do? What do they give me? Infrastructure as code. Actually, do I need to know a programming language? So I think it can seem extremely daunting, but I think what I've found is, like anything, you sit down, you pick a topic, and you go after it to understand. And I think another big thing is that no one is going to be a DevOps expert. No one is going to know CI/CD pipelines, programming languages, Linux. They're not going to know absolutely everything. You need to know a bit about everything. And I think that's probably my biggest advice to anyone is don't think that you have to get to the top of Everest on every single topic when you can actually just get to, well, just keep going up and down from base camp to a little bit more, and you're gonna be in a much better position.
Very wise advice. Yeah, thank you. This question from Ned. He's asking, does the 3-2-1 rule still really apply when it comes to Kubernetes?
So I actually did a talk at KubeCon this year, my first KubeCon. Exactly like I said, around the data management challenges, it's kind of no different. Like if you've been focused around backup in virtualization, cloud, whatever, then it's still relevant. Like having that 3 copies of your data on 2 different media types, with one of those being offsite, kind of gets you out of jail when there's any failure scenario at all, right?
Absolutely, yeah. Let's see, does this follow-up question here, does storage diversity create more opportunities for exposure and potential compromise of the data? If you follow the 3-2-1 rule, I guess the answer is no.
Yeah, I think Kubernetes itself as a project has really honed in on making storage easier. So yeah, I think there's 2 aspects to it. 3-2-1 kind of protects you from that because you're on different media types and you're kind of out of band from the Kubernetes cluster at that point. But I also think that Kubernetes itself, with the CSI driver, the in-tree provisioner, or the advancement of the CSI driver, really allows us to take advantage of a lot more of the different storage vendors and the capabilities out there to be able to protect and give us more functionality under the hood when it comes to protecting those workloads. Things as simple as snapshots are a great way of being able to keep stuff away from the bad actors, even as simple as a snapshot.
Okay. And then this question, they're asking if Kubernetes is more complex, does it take longer to restore from a backup compared to an application running on, let's say, a VM?
No, because simply put, so a virtual machine, you're looking at gigs of data. With a container, you're looking at megs of data. So you're already reducing the footprint overall. Yes, you can have lots of data. Like if you've got a database, you're going to have gigs of data potentially. But the laws of physics state that if I need to get 10 gig from A to B, it's going to take that long based on the network throughput, the bandwidth that I have. So it doesn't really change too much around the restore pattern. Just know that like casten K10, for example, can be quite granular as well. So you pick and choose what you restore, as well as getting into that database. It might not be that we need a whole database restore. Might just need individual tables or such like out of that.
Okay. And then when you look at backup in DR, do you see most environments utilizing a single solution, single vendor for all objects, whether they're in on-prem, cloud, Kubernetes, and also a single administration or team to administer it?
So this was an eye opener actually. So obviously Veeam, well, maybe not obviously, but Veeam acquired Casten back in October 2020, and we'd already been partners with Casten for a good 18 months before that, and we were working on integration points. But my initial thought was, well, surely the virtualization admin, the cloud admin, they're going to want their bespoke systems. They're going to want Veeam backup for cloud, whatever cloud. They're going to want Veeam backup for Veeam backup replication for their physical, their NAS, and their virtualization. And then they're going to want K10 for their Kubernetes. But actually, what we've seen is a lot of customers do want that. They want their point solution, and because it's a different team. It's the DevOps engineer, the DevOps architect that wants to look after or needs to look after the Kubernetes environment. But then more and more, as we're speaking to Veeam customers, there's a requirement to have that central management console. So that's one of the things. The first port of our integration brings in the ability to send our K10 backups into a Veeam backup replication repository, and then thereafter within VBR being able to manage those. So that's a little bit later on down the line, but kind of a bit of both, and it depends. And that's kind of an ethos from Veeam as well, is that we've got this central management tool that you can have, VBR, and it has the ability, we call it platform services internally. That gives us the ability to bolt on Veeam backup for AWS, Veeam backup for Google, but also our agents, as well as in the future being able to do K10 as well. And you pick and choose. Like if you want a point solution, you can have that. If you want all in one because you're the same team, then you've got that as well, the option.
I like that. Yeah, you've got kind of the best of both worlds there, or all worlds, best of breed. Excellent. Let's see. When it comes to getting started here, what's kind of the ramp up time for those who maybe have a Kubernetes environment? Maybe they're backing it up with, just whatever their backup tool is now. What's the ramp up time to get started with casten K10?
So really simple is that it's a Helm repo add our casten K10 Helm chart or Helm repository, then Helm install and a couple of Helm values, and you're in. Depending on where you're running it, there's obviously values depending on where that is. Then from there, you start you expose the service or you port forward the K10 dashboard. You're then in, or you could leverage the Kubernetes API that we're bolted into or integrated into, and then add in your export location, so your object storage or NFS or VBR repository. And providing you've got applications in your Kubernetes cluster, you create a policy and you're away. I think you could probably be up and running with backups easily within 30 minutes.
That's awesome. And I think that's a great question to kind of wrap up with here. We've covered most of the questions out there in the queue, most of them that we have time for. And I know we're kind of trying to keep this short. So if folks want to try out casten K10 for themselves, there's the QR code there on the screen. Anything else that we need to know, Michael?
Yeah, I think it's also worth, depending on how you consume resources, we've done quite a lot of research work with 451, but also ourselves, like talking about these 7 critical reasons. That white paper goes into a lot more detail than I can get through in 40 minutes. And then there's also, okay, now we're there. What do the best practice look like? What does the field tell us about best practice when it comes to Kubernetes backup? So there's some really useful ebooks that are available out there as well. Yeah, I think that probably covers it. But yeah, also any reach out either from a Veeam or Casten Twitter handle, but also my own at Michael Cade1. I'm more than happy to help out whoever needs some guidance on whatever.
Awesome. Well, I learned a lot about this. I mean, this is a hot topic so many companies are looking at today and need help with. So thank you so much for educating us on the 7 key considerations for Kubernetes backup. Excellent presentation. Thanks for being on the event today, Michael.
Cheers, David. Thank you for having me.
And thank you to everyone else out there in the audience for joining us on the webinar today. Don't forget about the QR code there. You can just scan with your phone, check out casten K10. There's a free trial. Try it out for yourself. Like Michael said, 30 minutes to get started, get up and running. So super easy to get started and start protecting your cloud native applications. I want to thank everyone out there in the audience. And before we go, announce the winner of our Amazon $300 gift card door prize. This is going to Douglas Woodington from Michigan. Congratulations. We will reach out to deliver your prize and also reach out to our best question prize winner as well. Visit casten.io for more information, and we'll see you next time on upcoming Veeam TrailBlazer Talks. Thanks a lot.